Alright, today we are taking notes on section 4.7, inverse trigonometric functions. And we're actually going to start today a little bit different than the normal video, and in fact I've actually got a little mental math question because we've been working with the unit circle so much. Alright, what I'm asking you here is the sine of what value is equal to 1/2? Right, so let that sink in for a minute, give that actually a good amount of thought. I'm hoping you're thinking in radians. You could say the sine of pi over 6 is equal to 1/2. That is completely correct. And my question to you is that the only value you can take the sine of and get 1/2? And I hope you're saying no, because there's actually another value you should know right off your unit circle. You would say sine of 5 pi over 6 would also equal 1/2. Right, and you can double check that on your unit circle. That's in quadrant 2. That would also be equal to 1/2. So are there only two answers? And I would hope you would say no to that question as well. So if there's not just two answers and there's more than two answers, the question is how many answers are there? And there's only one way to describe it. Infinite. And why do I say infinite? Well, this circle keeps repeating on the unit circle. So if pi over 6 has an answer of 1/2, if I add 2 pi to that, I'm also going to get another answer of 1/2. So that would be sine of 13 pi over 6 would also equal 1/2. So there's an infinite amount. All I got to do is find more coterminal angles with pi over 6 or 5 pi over 6, and they're all going to be possible values for x. So if you can answer these questions, then you have the basics for sine inverse, because we'll talk about that in a second. But here's a very similar, the sine of what, the sine of x, the sine of what is equal to negative radical 3 over 2. On the unit circle, there's two answers, although again, here there'd be an infinite amount. And you could say negative, so possible x values here, negative 4 pi over 3, and positive 4 pi over 3. 4 pi over 3, and another answer would be 5 pi over 3. You can double check both of those. They're right off your unit circle. If I took the sine of 4 pi over 3 or 5 pi over 3, I'm going to get negative radical 3 over 2. Okay. So, hopefully from the earlier part you picked out there are an infinite number of answers to this type of question. The sine of what is 1/2, or the sine of what is radical 2 over 2. It comes up in two places. Right? There's an infinite number, more than just two. There's an infinite amount. So what sine inverse is these are sine. The way sine inverse works is that when you are looking for sine inverse, you are saying the sine inverse of 1/2 is, this is the question we just answered. This statement is exactly the same as this. These two are equivalent. So this is the notation that we're learning today. We've already answered questions involving sine inverse. There's only one difference, and it comes with this paragraph. The answer to an inverse sine function will always be between negative pi over 2 and positive pi over 2. That is the hardest part of this lesson. Why is that true? Well, first off, we've already said that if you try to answer this question here, it has an infinite amount of answers. So we want to get it so that in math, we want to all get the same answer. So what we're going to do is, if we're talking about sine inverse, if we use this notation, we are going to restrict ourselves to from negative 1/2 pi to positive 1/2 pi. And they say, well, negative 1/2 pi isn't on the graph. And I say, yeah, you're right. Negative 1/2 pi isn't on the graph of our unit circle. But it's a coterminal angle. Negative pi over 2, this would be negative pi over 3. Over here, this would be negative pi over 4, followed by negative pi over 6. Those are all on the unit circle. These are all coterminal. And then obviously you have positive pi over 6, positive pi over 4, positive pi over 3, positive pi over 2. Those are all values there. And if I look at just my sign values, right? If I look at just my sign values here, looking at all of my sign values along the unit circle, I go from -1, the minimum of a sign graph, to 1, which is the maximum of a sign graph. So if I restrict my answers to negative pi over 2 to positive pi over 2, I will be able to cover every single number that a sign graph covers. It goes from the bottom of a sign graph to the top of a sign graph. So if I think of the outcomes, sine inverse is really working backwards. Okay. Here on the bottom there's some acceptable notations. So I already told you that essentially sine inverse, another way of writing it is if you switch x and y, well, the sine inverse of x is equal to y. Well, I could switch it and say sine of y is equal to x. So there's these two statements are equivalent. Another way to write sine inverse is arcsine. So this means this is another way of writing sine inverse x. Excuse me, those are just notation pieces. All right. So hopefully we can answer this. If you have a unit circle handy, it's definitely going to be of help. So remember, all of our answers are going to be between negative pi over 2 and positive pi over 2. Okay, so this is saying the sine of what is equal to -1/2. And there's only one value in this range for which that's true, and it is negative pi over 6, which would be your answer. Again, the sine of what is equal to radical 3 over 2, again, has to be in our same interval, has to be up here, has to be in that interval. Looks like, to me, that's got to be pi over 3. And last but not least, the sine of what is equal to 2. And I hope that would bring up a red flag, because you know the maximum and minimum of sine. Maximum for sine is 1. The minimum is -1. So there is no solution to this problem because you cannot, no solution. You cannot take the sine, no solution. You can't take the sine of anything and get an answer of 2. Okay, so excuse me. So if we're going to take the arc sine of x, or if you prefer, if we're going to take the sine inverse of x, remember, those mean the same thing. What values can we take the arc sine of? It's going to be the values that are. It's going to be the values on the unit circle. We are capable of taking the arc sine of x if the number's on the unit circle. So think of your y coordinates on the unit circle. They all fall within a certain range. They fall between -1 and +1. We can take the arc sine of any number between -1 and 1, which is why in the last problem we couldn't take the arc sine of 2. That didn't have a solution, because it doesn't fall between -1 and 1. And we already answered this question. If you're really sharp from today, we've already determined what all of our outcomes are between. All of our outcomes are between negative pi over 2 and positive pi over 2. So that's really a focus on sine inverse. We're going to continue by looking at this in a very similar method. I'm hoping not to spend quite as much time on it because it's essentially exactly the same for cosine. This notation is cosine inverse of radical 2 over 2. That's what I'm essentially asking you. And if you think of it like this, well, then there's a lot of answers, right? You would agree that there's an answer at pi over 4. There's also an answer at 7 pi over 4. And anything coterminal with that would be an answer. So there are plenty of, again, an infinite number of answers. Here, for this problem, you would have answers at 3 pi over 4, 5 pi over 4, and any answers coterminal with that. So again, we have some problems. We have 3 similar ways to write cosine, or cosine inverse, arc cosine, cosine inverse. And again, if you ever want to go from a arc cosine over to a cosine, all you have to do is switch the location of your x and your y coordinates. Those would be equivalent. Here's the tricky part to cosine, this last part. When you take the arc cosine of a number, your answer must always be between 0 and pi. Why is it now? Well, in the last one, it was negative pi over 2 to positive pi over 2. Well, we're now looking at cosine. Cosine's values are a little bit different. If I look at my cosine values from 0 all the way to pi, cosine values start at 1 and they decrease. They go all the way to 0. Now they start going into the negatives, and they finally hit negative 1. That's the furthest they go, and then they start retreating back. So if I look from 0 to pi, I cover from 1 to negative 1. That's the maximum of cosine all the way to the minimum of cosine. It would not work if I tried to use the same location. If I just used this half of the graph, if I just used this, notice that would only be positives. So I would not be able to do it just like sine. So you have a couple exceptions here. You have to be careful with cosine inverses and sine inverses because their answers are in different quadrants. All right, cosine inverse answers are always in quadrants 1 and 2, between 0 and pi. There's many ways to state it. So let's look a little practice here. Arc cosine, cosine inverse of radical 3 over 2. That's going to be in quadrant 1. You're going to say that is pi over 6. Where is cosine inverse equal to negative 1? That's going to be when you're equal to pi, anywhere from 0 to pi inclusive. All right, again, I can't talk about coterminal angles because now that we're using the arc cosine notation and the cosine inverse notation, it has to be an answer between 0 and pi. Nothing else is acceptable. Even your calculator will answer between 0 and pi. Okay. Tangent works in a very similar way. If I tried again, what this question is really asking us is tangent inverse of what? Tangent inverse of what? We'll call it x is equal to 1. I'm sorry. Yeah. I'm sorry, I'm writing that wrong. The tangent inverse of 1 is what? So this is what we're asking. The tangent inverse of 1. What values could I take the tangent of and get an outcome of 1? And I changed this unit circle because it gives us all of the tangent values out here. It's a little hard to see, but it does tell you all of your tangent values. I'm going to erase them, and I'm going to say, clearly, pi over 4 would be an answer. But I think it's also pretty clear that 5 pi over 4 would also be an answer. And again, just like cosine and sine, tangent has an infinite amount of answers. So because of this, we need to restrict the answer range. What do I mean by that? Well, similar to sine, our tangent answers fall in between our asymptotes. So the easiest way to say our tangent inverse answers, yes, I know this is undefined. So you can't technically have an answer of undefined, but you could have anything from negative infinity all the way over to this is an answer for tangent to this is an answer for tangent. So we're looking at angle measures that would be between negative pi over 2, which is what I would call this, negative pi over 2. Right, similar, I call this negative pi over 3, negative pi over 4, negative pi over 6. Similar to what I did with sine. We already know this is 0, pi over 6, pi over 4, pi over 3, and pi over 2. Those are possible outcomes for tangent inverse questions. All right. The one thing I will notice there is no line here, no line underneath. It is not possible to have a tangent inverse of negative 1/2 because you're never going to be able to use undefined. That's where our asymptotes are. If you think about where your asymptotes are when you graph tangent, that's what's going to tell you where your restrictions are for tangent inverse. It's the same place your asymptotes are located. The last part to this is just a little notation down here at the bottom. Same as before, arc tangent, tangent inverse, and if you switch x and y with a tangent inverse, you get a tangent equation. All right. We will talk about this. We will start here in class. Next time I see you, I'll be checking your notes. Enjoy the rest of your day.